Hello everyone. In last video we have seen the replacement model type 1 questions. Now let us see the replacement model type 2. Replacement of atom that fail suddenly. In this video we are going to see the replacement policy for the atoms which are suddenly get fails. In a previous section we considered replacement of atom that deteriorate with time, resulting in increasing its maintenance and operation cost. However, there are many real-life examples in which atoms do not get deteriorate with time but fail suddenly. It is therefore quite important to know in advance as to when the failure is likely to take place so that atom can be replaced before it actually fails. Now we have the two replacement policy, that is optimum cost group replacement policy and optimum individual replacement policy. The formula for this optimum group replacement policy, this is OCGR is equal to CG n plus Ci summation of n of k divided by k, and the formula for the optimum individual replacement policy, OIRP is equal to Ci n upon summation of k dot pk. For the better understanding of the given formula and the variable present in this formula, we have to consider one simple example. So let us take an example. The failure rate of a certain type of electric bulb is shown in the table. There are 1000 bulbs in use and it costs rupees 2 to replace an individual bulb. If a bulb are replaced simultaneously, it costs rupees 0.5 per bulb. Decide the optimum replacement policy. This is the given data of the bulb. In first week, the percentage of failure is 10. In second week, that is 25. In third week, the percentage of failure is 50. In fourth week, percentage of failure is 80. In fifth week, percentage of failure is 100. Now we have to decide which optimum replacement policy is better for this problem, whether it is group replacement policy or individual replacement policy. It means that we have to calculate which policy gives the least cost for replacement. Now let us see the solution. The given data is number of bulb 1000, cost for individual replacement 2 rupees given in the question, cost for group replacement 0.5 rupees given in the question. Now let us make a table. V, percentage of failure, P of k, N of k, summation of N of k, OCGR. As given in the question, the number of weeks are 1, 2, 3, 4, 5 and the percentage of failure 10, 25, 50, 80 and 100. So write here 1, 2, 3, 4, 5. This is the number of weeks. Their percentage of failures are given in the question: 10%, 25, 50, 80, 100. Now calculate the probability of failure. That is, for first it is 0.1, divide 10 by 100. Now for second, 25 minus 10 divided by 100, that is 0.15. 50 minus 25 divided by 100, that is 0.25. 80 minus 50 divided by 100, that is 0.3. 100 minus 80 divided by 100, that is 0.2. Now we have to calculate the N of k. To calculate the N of k, we have a formula. N1 is equal to N0 into P1. N2 is equal to N0 P2 plus N1 P1. N3 is equal to N0 P3 plus N1 P2 plus N2 P1. N4 is equal to N0 P4 plus N1 P3 plus N2 P2 plus N3 P1. For N5 we have formula N0 P5 plus N1 P4 plus N2 P3 plus N3 P2 plus N4 P1. एक चीज़ आपको इसमें सिमिलर दिखेंगी, जैसे N0 इंटू P1 है, इधर N0 इंटू P2 प्लस N1 इंटू P1. ये N0 N1 N की वैल्यू बढ़ रही है और पी की वैल्यू 2 1, ये डिक्रीजिंग ऑर्डर में और एन बढ़ रहा है, जैसे यहाँ 0 1 2 3 2 1। इस प्रकार आप सिंगल अगर आप ये एक फार्मूला याद रखते हैं तो आप बाकी के फार्मूले इजीली बना सकते हैं अपने आप। सो लेट अस कैलकुलेट द एन के वैल्यू। इस रफ पेज पे मैं सॉल्व करता हूँ। n1 इज इक्वल टू n0 इंटू p1, n1 इज इक्वल टू 1000 इंटू p1 0.1, n1 is equal to 100. Similarly, n2 is equal to n0 p2 plus n1 p1, 1000, n0 की वैल्यू 1000 है, जो हमने इसे n0 लेना है, हमें n को n0 लेना है। सो इट इज 1000 इंटू p2 दैट इज 0.15 प्लस हमारा n1 कैलकुलेट किया है हमने 100 इंटू p1 0.1 that is 160. Similarly, n3 is equal to n0 p3 plus n1 p2 plus n2 p1. n3 is equal to 1000 into 0.25 plus 100 into 0.15 plus 160 into 0.1. Therefore n3 is equal to 281. Similarly हम n4 और n5 भी निकाल लेंगे। n4 है 377, n5 349.7. Now write all this n value in this nk column. 100, 160, 281, 377, 349.7. Now we have to calculate the summation of nk value. For the first, that is same 100. For the second, 100 plus 160, that is 260. 260 plus 281, 541. 541 plus 377, 918. 918 plus 349.7, 1267.7. Now we have to calculate the optimum cost of group replacement. For this we have formula. So for the first, Cj value is given 0.5, n is 1000, Ci is 2, summation of nk for the first week is 100, and the k, that is week, is 1. So the value of this calculation is 700. Similarly, for second, the only change in this is summation of nk value and k. Therefore 2, this is remain same. Summation of nk for the second 260 and k is 2. The value is 510. Similarly, calculate for the all other three. I have calculated for the other three values similarly. That is 354, 584, 607. Now we have calculated the optimum cost for group replacement. One thing you observe in this values, the values is in decreasing order, and at this point the value is suddenly increased. The value is in decreasing order, and at this point the value is increasing. So this is the average group replacement cost. Now we have to calculate the individual replacement cost and compare with this cost. Optimum individual replacement policy is equal to CIN upon summation of k dot pk. CI value is 2 into n 1000, 1 into 0.1 plus 2 into 0.15 plus it is a product of k dot k and pk and their summation. So 3 into 0.25 plus 4 into 0.3 plus 5 into 0.2. By calculating this, we get the OIRP 597 rupees. Now compare both the OCGR and OIRP. OCGR is less than OIRP. हमें ग्रुप रिप्लेसमेंट 354 रुपीज़ में पड़ रहा है और इंडिविजुअल रिप्लेसमेंट 597 रुपीज़ में पड़ रहा है. सो ये कम है, इसलिए ये हमें परवड़ता है. सो ग्रुप रिप्लेसमेंट वैल्यू इज लेस, इट इज़ लिस्ट, सो इट इज़ अफोर्डेबल फॉर द ऑर्गेनाइजेशन to replace. Therefore, we select OCGR technique to replace bulb. Thank you. If you like the video, please like, share and subscribe. Thank you very much.